All right, this is lab one, the tape lab. So for the introduction, the concept that we're going to be discussing is Coulomb's law and the point charges, the basics of electric fields, and basically treating each tape as a single point charge, which is also one of the assumptions that we're going to be using later on. The goals of this lab was to observe how charged objects interact with each other. Do they repel? Do they attract? And to also calculate the electric charge between two charged particles using the observations that we observed. So for the first part, we basically had two strips of tape, and the questions that were asked was if a pen was negative and then got a positive, you had a positive tape, what would happen? They would attract. Second question was if the tape was negative, what would happen? And they would repel because two like charges repel. And then the third question that was asked was if it was a neutral tape instead, what would happen? And it would attract because when it's neutral charge, it doesn't matter regardless if it's a positive or a negative charge. It always attracts to a neutral, and this also causes an induced dipole. Um, it and then after and then in the final part of this part seven, we had to we got a plastic pen that is known to be uh, negatively charged. Uh, so we got a U tape and got it next to the pen, and uh, the 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 pen and the tape both attracted. So based off of this, we could conclude that the U tape was positively charged. So a couple of assumptions for the next part. First assumption being we treat each strip of tape as a single point charge. And the second assumption being that each tape has the same charge and magnitude. Obviously, it might not because this is all kind of just estimating. But for this case, we're going to assume that it does. And another assumption is that all the atoms are of the same size and they're tightly packed and arranged into like nice columns, rows. So for part eight, basically as the picture shows right here, the two strips of tape, one below the other, and basically we observed that they repelled, and they repelled because they're both positive charges. And using a ruler, we observe roughly a 1 centimeter displacement. Uh, and yeah, so two like charges. And then, so here are all of my calculations. So to do so, to find the actual charge of point C, we had to draw a free body diagram of the tapes. So we use Newton's third law, which states that each particle there must be an equal force opposite to the other. So which is the gravitational force and the F electric force. So here to calculate the charge, we use Coulomb's law, and we come up with a result of 4.67 x 10 to negative 9 coulombs. And and in the next part, we discover that there is a deficient of electrons on the tape. And below are my calculations for the amount of atoms and the ratio of electrons to atoms. And here is my code. Everything is printed out, and the bottom one is tape B, and top one is tape A, and both of the arrows showing the two forces acting on tape A. So for my conclusions, to conclude, if the question was asking if the signs of the electrons and protons would change, what would happen, and uh, the tapes would instead of being a negative charge, they would be a positive charge, causing an excess of electrons um, Yeah. And the second question, it is very important to handle the tapes as little as possible because the tapes, they're since they're very sensitive to like the charges. You never know, you could lose a charge, causing us to like redo the experiment. Things I learned how point charges work in the real world, and it was a good like real life application to put it into action.